University. We are really excited to be hosting Jared Friedman today, one of the original and still Your Desk hosts, or I guess initiators. Also, I'm not going to be hosting today. Lebo, who did the session earlier today, is going to be hosting, and we're going to be talking about web applications. Really, really simple web applications. And looking forward to hearing about it. I do a lot in JavaScript when I'm doing web, but this is going to be specifically focused on Python. So with that, I want to bring onto the screen my other host, Lebo, who you can see on the far side. Let's see if I can point the right direction here. And then Jared, who is in the center there, between two hosts. But with that, I'm going to hand it over to Lebo. I'm so grateful to both Lebo and Jared, and you can't see him, but behind the scenes, John, who is making sure the audio is all working. I'm looking to make sure. And with that, Lebo, I will hand it off to you. Thanks for hosting today.
Hey, hi everyone. As you guys heard from Timon, that we're hosting Jared today. There's no one I'm more honored to share a doubleheader with. And, of course, Jared deserves the prime time slot with an exciting introduction to web development with Python. Jared, do you want to give a quick little self-intro?
Sure. I'm Jared Friedman. I am a senior technical designer at Walter P. Moore in the New York office. So yeah, I do a lot of work in kind of the computational design realm, where a lot of the sort of audience and people interested in Your Desk, I imagine, are. So
yeah, thanks Jared. Thanks Lebo for being on. And I totally forgot to introduce him, but Jared is one of my coworkers at Walter P. Moore, where we both get to do a lot of programming as parts of our jobs. But yeah, why don't you guys get started?
Show us what you got, Jared.
All right. Yeah, so I'm gonna do a very quick slideshow, and then I'll kind of jump into the demo itself. So yeah, so this will be kind of, my background is as an architect. So I'm not, a professional developer by any means. So everything I've learned, I've just kind of picked up through online courses and coworkers and whatnot. So when I go, a lot of times things will come up when people might ask for a quick kind of web app, or maybe you just are doing something that you say like, hey, I just want to spin something up, or maybe I just want to prototype something. And like, my day-to-day isn't enough in like JavaScript, HTML, CSS that I want to deal with it. I mean, I've done it a little bit here and there, but every time I do it, there's always like that like first few hours, or I'm just like, what is this again? Because I'm always like, I'm always a little rusty. So most of the time when I am programming, I'm in Python. So if I'm doing a quick kind of study of something, if I can like prototype or make a quick app and be able to stay within the Python world, for me, that is usually a lot more efficient to work that way. So Streamlit is like a really good open source, free kind of tool where people can make web apps. So Streamlit, you can, like with any Python, when you're using Python, you can bring in packages. It's kind of built to work well with certain packages more so than others. It particularly kind of lends itself towards like data science and machine learning type applications. So you'll see things like Plotly and Pandas play really well with Streamlit. But you can bring in any module pretty much. And then one of the modules I'll be kind of bringing in during this demo is the EC3 Python wrapper, which is kind of a shameless plug for a little side project that I had done a couple of months ago. It's still, I guess, I haven't updated it in a couple months, but it's open source, so hopefully I can continue to develop. And I'll talk a little bit about that, but I won't really be doing a deep dive in that. I'll be kind of trying to quickly go through and focus more generally on like Streamlit. But yeah, this is the EC3 Python wrapper. I can throw some links in the chat here in just a minute. But yeah, so this is the GitHub, and there's a link on the GitHub page. There's like links to read the docs and whatnot. But basically,
you have another slide, but can you tell us real quick generally what EC3 is, what it does, what we can use it for?
Yeah, so EC3 is like an online, they store environmental product declarations, essentially. It's a database which so any like art, like building material or concrete mix is kind of the big one that's in there. You'll have what's called an environmental product declaration, an EPD. And so all the information about like the manufacturer and environmental properties and material properties are all stored on there. Um, and so EC3 has it's run by a nonprofit called Building Transparency, and they have an API that's accessible to anyone. um, the reason I kind of made the wrapper is that the API is very kind of cumbersome and difficult to work with because there's just so much information in there. And so a lot of what the wrapper is doing is trying, as I was working with the API, I found myself doing a lot of the same things over and over again. And so I tried to kind of like take some of those really common things. For example, if you query anything, it'll give you a bunch of null properties. So even if I'm querying like steel, it's just going to give me like the concrete aggregate size, and it'll just say null. So I have some stuff in there that'll just like automatically filter out like all the nulls if you want, which is usually what you want to do. So just things like that is kind of what the wrapper does in the background, and then we'll leverage one of the other kind of main functions that I built into it during this uh, during the demo, which is allowing you to kind of query it by region, um, which is like not really easy to do purely using the API because you kind of have to get like the plant manufacturer, you have to get the latitude and longitude, and then like do kind of a lookup in terms of distance from that latitude and longitude. So there's a few steps that I kind of just built into one thing. Um, overall, I would say it's really good for, doing simple apps with limited scope and few inputs. It's really good for just like kind of prototyping. If let's say you were going to build out something a little bit more robust and like something that was going to be used by hundreds of people, Streamlit's probably not the best tool for that, but you can use it to maybe prototype something for that. And a lot of the examples that you'll see online are for like interactive apps for like ML and data visualizations, where say like you're loading a data set and then you're kind of querying it. So that's kind of a pretty common way in which you'll see it used. And I'll show a couple of examples here in just a bit. So I'm a big fan of Streamlit, but at the same time, you have to acknowledge that it's really not the best tool for everything. There are, so anything that's going to require a lot of processing of the code, it's not really great for because the way it works is that it reruns every time kind of like the page is refreshed. It's basically rerunning an entire Python script. So if you're starting to get into something that's more computationally demanding, it's not a very, it's going to be very slow compared to, JavaScript or something else. Any apps that are going to require manipulation of a lot of inputs, like I said, because every time you change an input, it's going to like rerun the script basically. Now there's some things with caching and session states that I'll talk about a little bit that help manage that, but you'll kind of hit a ceiling pretty quick. And then anything that requires a lot of customization of the layout, you are kind of like sort of constrained. I mean, you can set some styles with color and fonts and things like that, but like you're generally going to be constrained to like a sidebar and like a main bar, and then you can have like pages too, but there's really kind of a limit to what you can customize. As far as deploying Streamlit apps, so you can deploy them in the Streamlit community cloud if you're making them publicly available. So like the one that I'll be showing, I'll share a link. So basically the way that works is you sign up for Streamlit, it's free, you create an account, you publish so like if you have everything that is going to be contained in your app would be on its own GitHub repository, and then you just kind of create the link between Streamlit and that repository, and it basically will serve that app for you. And I forget what the exact limit is. I think like after like 7 days, it kind of goes to sleep, so that they're not like constantly, every app that was ever made isn't constantly like being saved on their server or whatever. So I don't know all the details of it, but basically like it's kind of meant for, like testing out, and if it's good for that. And I mean, you can share it with however many people, and as long as people are going to it, it'll stay active basically. And then you can also like if you're creating something that's internal, so let's say like you just want to share it among your own company or something, you can also just create like a Docker image, and there's ways to deploy it using Docker, or like things like Kubernetes and some of these other ones that you see on the screen here that are kind of, I guess, built as extensions of Docker more or less.
So I have a quick
But
question. Do you have to do like a little bit of pre-planning when you're building something with the intent of a Streamlit app, or is this something you kind of build logic first and then can add on later when you decide that you need like an interface or something to share?
um, yeah, it's a good question. I think like, I mean, you can if you're building things in functions, like you can always kind of like shift it around. You'll see as we get into the example, like Streamlit is very like kind of like has its own way of like doing things, and so you do kind of like it's usually at least the cases that I've used it. I've like gone into it knowing I'm going to make a Streamlit app. Um, so I would say it's harder to like take if you have like some long like script in like a Jupyter notebook or something, there'll be some like kind of processing that you'll have to do in order to get it to work in a Streamlit app. So usually if you're gonna try to, I would recommend like trying to know ahead of time if you're going to do that. And so yeah, so this is kind of an example of like from this is the guy who like made Streamlit had there's a he has this article. It's a few years old now, but it's still kind of nothing's really changed that much. So like this is kind of how he outlines a typical machine learning engineer's ad hoc app, building flow with Python is, you're going to have a Jupyter notebook, then you're going to like, let's say you want to like make it into an app that you're going to share. You might have to like take that into a Flask app and then think about the requests and all these types of stuff. And then like once you deploy it, once you need more features, you kind of have to go back and do this whole thing again, and it becomes difficult to maintain. Um, so this is kind of like the Streamlit workflow is, this is coming from the person that made it, keep in mind. But it is really very easy, as we'll see. You kind of can just write, a few lines of code and be able to get an app really quick. And so this is what, I can't see everyone's faces, but I'm imagining everyone's like blown away by this, right? Um, and then like as far as like how the app is being rendered and caching and stuff like that, basically you run it, you can cache like let's say you upload like a data set of, transportation. I don't know, like I'm just looking at the image here, like Uber pickups in New York. You can load that, cache that data set, and then like continue to like rerun the script as the user is like interfacing with the data without having to constantly reload that data set. So there's ways of like caching and storing things without having to rerun the entire thing every single time. But then the app state basically gets updated every time the user is changing their inputs. All right, so with that, I'll kind of jump into a few things here. One thing, so yeah, so I'll kind of point out the Streamlit. This is like their site. Let me see. I can drop some stuff in the chat here. Their documentation is really, really good. So like I'm gonna gloss over a lot of stuff because if you are like trying to build something, like everything is really well documented here. So I definitely recommend checking that out. The EC3 Python wrapper that I had mentioned. Here's the read the docs. Let me. I'll just share the GitHub link. And what else? Oh, I guess here's we just wanted to look at like EC3, the API real quick. Like this is just like a materials list, like all the stuff that's in there. So there's like it's very cumbersome as you can kind of see to work with. So that's it takes a while to kind of know what to look for when you're searching for these things on their API. And also the Streamlit, maybe before I jump into the demo, I'll show a couple of, they have like a gallery on their website. Or I guess I can just Google it. But anyway, I pulled out like a couple of examples So like here's an example of an app that like you can feed it a bird. So if I wanted to say like, this is like a machine learning image, if I could get a black vulture, like it has like a bunch of different black vulture images, and then it'll tell you, the confidence level based on the image, like what that is, and you can upload. If you have a picture of a bird that you're not sure what it is, you can upload your own picture of a bird, and it'll kind of take a guess. So it's kind of a this is kind of a pretty typical type of app that you'd see, and you see how fast it is because it's like loaded the ML model in the background and kind of cached it. Um, so it is like pretty fast for these types of things. But like you'll notice there's not like a ton of interaction on this interface. Like it's kind of um, just meant to do like this one specific task, which is typically what you see in like a Streamlit app. Another example actually is kind of like ties back to some of we had the pollination. I think Chris Mackey from Pollination was on last season at your desk, and he showed some of their stuff, and they use Streamlit for some of their apps as well. So they actually have. I'll drop this in the chat stuff, and they use Stream. So they have like links to some of their apps here. So if you wanted to, and like they actually have some of the ones that I poked around on there are like a little bit more advanced in that they'll integrate like 3D visualization stuff. It's a little bit slow, but we'll see if that comes up. Okay. Maybe we'll come back to that then. And I guess the other thing before I jump into the tutorial is I made like a little blog post that runs through everything I'm going to do here. So again, I'm going to be going like really fast. But for anyone who's like wanting to actually try to do this themselves at some point in the future, you can kind of use the blog link here, and it'll go step by step, setting up the packages, setting up the files, and then I've kind of broken the app down into steps, and these are all linked to the GitHub, which is this. So basically what you see here, in this repository, this is the repository that I made and then connected to Streamlit. So I have a bunch of files in here that kind of go through the steps that Streamlit's ignoring, because I just tell Streamlit, hey, look at like this one, the final step, or the demo app.py. So it'll kind of look for specific things when you make the connection. So it's not gonna necessarily, you can have other stuff in your repo, without having that necessarily be something that shows up on Streamlit.
Lots of good self plugs in this one. Make sure you check out all of Jared's stuff.
I just figure it was easier for people to kind of reference the links later on, as opposed to trying to build a lot of this from scratch. So yeah, here's the pollination one. They have a cool little like, sun path map. So you can like change the angles and, set the latitude and longitude or something. And then, make this into, I'm guessing you can like download this as an image or something, or a model. So there's some cool stuff like that that Pollination has put out for some of their apps as well. All right. So I guess we'll just jump into it now. So what you'll typically be doing is, so you'll see here, I've got a few folders set up here. You really only need one Python file at the end of the day, which is going to be like this demo.app.py. You probably, if you're deploying this, you'll also and you're using other modules, you're gonna want your, typical kind of requirements.txt file that'll tell, the image what modules are being used. Then you'd also have in Streamlit, if you have a .streamlit folder, you can have like a config .toml file in there. And again, all of this stuff is like covered way better than I can cover it on the Streamlit documentation. But you can kind of set any configs on your Streamlit app. So the only one I'm going to really be using is I've set the primary color to be your desk purple. And then if you have any secrets, I won't open that one, but like if you have bearer tokens, so that's like going to be where I would store my bearer token for the EC3 library. Um, so you would basically just all that's in there is going to be like the variable name and then the token. And then in the later step, when you go to publish on Streamlit, you would just kind of have, there's like an area where you can set your tokens. And so as long as you kind of reference it here as you're testing locally, it'll know to use that variable. And then when you go to deploy it, you kind of just set it up to have a similar type of thing. All right, so I'll kind of start, rather than like typing everything out, I figured it would just be faster just because I'm pretty slow at typing. It'd be faster I can just kind of talk through what's happening in each of the steps here.
Before you dig into the steps, can you give us like an overview of what we're building?
Oh, yes. Sorry. So the app, maybe we'll kind of start at the end. Is this it? Yeah. So essentially what we'll be building is looking up within a certain region, and then given a certain radius with a specific concrete, PSI. So we can say like 6,000 PSI, and this is like the strength at 28 days. You can check whether or not you want it to be a lightweight concrete. And then I'm going to search for concrete materials that are available within that region. So this is kind of like a common thing you might, if you're, a contractor or an engineer or an architect, and you're trying to figure out like what are the available concrete mixes within a project region. You might want to know because concrete can only come from like so far away, to a project site. So this is kind of going to be where the first plot here you'll see is going to be, we're going to plot the global warming potential of the different mixes to see kind of what is available. And then the second part is we'll do a little map that shows where all of the concrete mix suppliers are located. And like we can kind of, it's in this particular case, it's hard to tell, but the circles are like different sizes, and you can hover over and see like how many EPDs they've uploaded into the EC3 database, and that kind of thing that are located here. So, and then like one thing you'll notice that's kind of interesting here is that, this is as far as like the kind of query that we're doing here, it's super simplified. In reality, you'd want to be looking at other things like aggregate size and like cementitious content and all this other stuff. I've like tried to simplify it for the purposes of the demo. But like something that's interesting here, just looking at this right now, is like you would kind of expect this to be more of like a normal distribution, but the fact that you kind of have like a cluster down here and then a cluster in the middle and a cluster up here tells me that like there's some other like piece of data or some other pieces of data that I'd probably like want to add to this query in order to kind of like get a better sense. But generally speaking, like this is going to be your box plot of like saying, the middle quartile of materials is going to fall within the range of a GWP of about 300 to 400. So that could tell me at least, let's say, and this is looking at around Washington, D.C. I'm doing a project in Washington, D.C. I've specified 6,000 PSI concrete. I have a pretty good sense of like that, 300 to 400 might be like a good range as like my baseline to estimate, if I'm trying to estimate my global warming potential for the concrete on a project, that might be like a good start. And you might want to be a little bit conservative early on, and then, but that, I could potentially get down to, 250 or even less if I am using the right mix. And so part of what building transparency in EC3 are trying to encourage here is also encouraging manufacturers to like make more sustainable materials, because if people are querying the database and they're going to say, I'm going to take the material with the lowest, carbon impact, like that's going to help to encourage manufacturers to produce, more sustainable materials. So we'll kind of that was a very long-winded answer to your question, Lebo, but we'll kind of build this up piece by piece here rather quickly. So when you import Streamlit, usually you'll see it kind of like you import it as ST. This is just, you can call this anything, but throughout all the documentation and everything, you'll see it as ST. So I'd recommend just kind of sticking with that. And in this case, we're going to like import just the Python image library to open an image, which I put in this images folder. This could really live wherever, but just for the sake of organizing it, I put it in an images folder. And then we'll kind of just create a button, a very simple button. So like this is all these things that are followed, st dot. These are things that are built in to Streamlit. So that
we do have an audience question that might be applicable here. So when you add Streamlit, it's just like normal pip install, or do you have to do something special?
Yep, it's just a normal pip install. There's probably, I think, some other ways to install it, but I just used pip install. And they have that on the website as well. I think they do have like a fuller down like installation that might have its own like interactive thing that allows you to run scripts. But when I'm doing it, at least usually I've just done the pip install, and then whenever you're kind of like ready to run the script in your terminal, you would just say Streamlit run and then the name of your Python file. So I'll just run the step1 _ start.py. And this is going to just run it locally. And it'll just like launch it here in the browser. So this is kind of the first step. This is the button, click me, and then it says you clicked me. So very exciting. But that's 15 lines of code. Whereas like if we were doing this with like HTML and CSS and JavaScript, like just to create the button and stuff, it would probably be a good amount more effort. So anyway, one thing I kind of mentioned, and I'm not gonna, this app doesn't use it because every time we're querying, I'm not interested in caching the data, because every time we send in like a new query, we want to get like a new response. But a lot of the times, if you are working in a case where you just want to upload the data once and then like do a bunch of stuff with it, you can cache it. The other thing that is also I found useful in some of the other apps that I've built is this idea of session states. So I'll just kind of create a little demo here to explain the concept of session states. But let's say, so also as I'm kind of going through, I'm gonna be typing Control-C to stop the app from running and to start like the next file. If you just X out of this without like stopping it using Control-C in the terminal, it's gonna like freeze up for like a minute or two. So I don't know why, but like I just find that it's good to do the Control-C route if you're trying to stop the app. So I'm gonna run this one just to demonstrate something about that concept of how Streamlit is rerunning every single time. So in this script, I have, a counter. I'm just like visualizing it with using st.write, and then I have a button. And in theory, what I want to do is I want to add one every time I click that button. But what you'll notice is that every time I click it, it's rerunning the whole script. So it's starting from the beginning and it's going back and setting counter to 0, which, a lot of times might not be an ideal kind of behavior for how you want the app to work. So that's where the idea of session states comes in, which allows you to store like variables basically that don't get like reset every single time the app is run. So if I were to just comment this out and bring it back here. So what we've done here is we've introduced this session state, and then you would just say the variable name after session state in order to like store it in the session state. And so now by using the session state, we can actually like get the behavior that we would expect. So the other thing you can do that's kind of nice is if I save this, as I kind of have both these screens up, if I save my script, it'll give me the option here to like rerun. So this way I don't, if I'm working within the same script, I don't have to constantly close and open.
Awesome. So hot reloads every time you change a script.
Yep. Yeah. So every time you save it, it'll offer you kind of the option to do the reload. So now when I'm doing this, now I kind of get the expected behavior because it's storing that counter variable in the session. And then if I wanted to reset it, I could do something like a reset button. So this is something that is often useful. In the particular example that I'm going through here, there wasn't really a good use for it, but I just thought it was something that was good to mention. All right, so we'll move on to step 2.
Real quick, Tim and John, I don't know if you guys are. Oh, there we go. Sorry, because we weren't seeing the whole screen before.
Okay. We're good now. Okay, cool. All right, so step 2 is going to be we're going to introduce the form. So a lot of times in Streamlit, there's this idea of like a Streamlit form, and this also kind of helps to address. I'll just close these and rerun the form one here. So what this does is it also helps us to address that issue of step 2 of like having to rerun every time. So rather if I have a slider or some sort of button in here, if I don't create a form, every time I like put something in here and like change this slider, it's gonna like try to rerun the app. So if I have multiple inputs that I want the user to put in before trying to like trigger the app, that's where forms come into play. And so you'll see here that I've just put it. You can do it just like st.form if you don't want the sidebar. A lot of the times I'm putting the form in the sidebar, so like you can do like sidebar.form to put the form in the sidebar, and you would just say it kind of like with st.sidebar.form. You can like name your form, and then so I'm putting in. There's this like I've kind of like just demoed a few of the different types of inputs. There's a lot more that I'm not covering here, but you can have a simple text input. You can have a number input. You can have a number slider, a checkbox. So I tried to like cover as many as many bases as I could. Even though in reality it probably would have been better to put like this, for example, as a number input that would limit the user to like a 5-digit number or something. But I just wanted to kind of show some of the different options here. So, and then once you submit the form here, so for this, just step 2, all we're doing is I'm just kind of printing out basically what we've done. And you'll notice one thing that's cool about st.write, which is kind of like Streamlit's print function, essentially, is that it could take in multiple types of variables. So, I mean, we're only showing it like a string and an integer here, but you'll notice like the miles integer is kind of like looks a little different. And you can even print out like an entire like pandas data frame and query it using just st.write. So you can print out all sorts of, you can print JSONs. So that's the st.write functionality is a really handy one as you're building an app. All right, so we'll move on to step 3.
Yeah, the form and the print alone probably saves you a ton of time, not having to configure a lot of the stuff that you usually do when you're building out an application.
Right. All right, so we'll go step 3. So this is kind of the step where we're doing the sort of the bulk of the work as far as the EC3 query. So I'm not going to go too much in depth of it, but I'll kind of quickly show a little bit. So far we've kind of gone up to here. So one thing that I'm checking first is like, did the user put in a valid postal code? And I just made a function for that. And it's really just checking, is it, a string of length 5, and can I turn it into an integer? It's in reality, I'd probably want to do a more thorough check, check it against some sort of database of postal codes to see if that actually exists. But for the sake of simplicity, I'm not doing that. And then we're kind of creating this EC3 materials object. So this is something that's coming in from from the EC3 Python wrapper. So I'm importing that EC3 materials class here. And what that allows me to do is create like a query of the materials database within EC3. And so kind of like any API call, I'll pass it a bunch of parameters and get back essentially like a JSON response. So these are the parameters that we're looking at. So I'm looking at, give me the things that are considered a ready mix by EC3. This lightweight is just going to be a Boolean. So if, true if it is lightweight, false if it's a normal weight concrete. And then the compressive strength is just expecting the string, which is kind of interesting because because you have in EC3 like multiple manufacturers kind of inputting their data, sometimes things will be in different units. So there'll be kind of another step here where we're going to have to do some cleanup in the next step to make sure that like everything's getting converted to PSI before we do the sort of like data visualization step. And then return fields, what this does is something in the wrapper that helps to limit the number of fields that you get back. So rather, if I'm only looking at certain fields, I can tell it just return these fields in the JSON response. Don't give me like everything because I'm not looking at the density right now. I'm not looking at, whatever like tensile strength or something. I'm just looking at like the compressive strength, the GWP. I want the name and then the planter group is actually kind of a nested, element in that it's going to give me like within that there's like the name of the plant, there's the address of the plant, there's the latitude and longitude of the plant, and so there's all sorts of other data within that we're going to look at. And then I've also so like one thing that's a little bit like risky here is like if I put a really big radius around like a major city like New York or something, I'm gonna get like tens of thousands of potential mixes depending on what I'm looking at, which would take a very long time. So for the purposes of keeping the query like at a reasonable time, I've just maxed it at 2,500 materials. And then this only valid is going to make sure that materials that are EPDs that are only valid like based on today's date, essentially. And so then we're going to, we just do this st.spinners, this kind of another Streamlit built-in thing that'll kind of just helps to cue the user that something's thinking. And so I'm going to actually, this might take a minute. I'm just going to put it in now as we're going and let this kind of, so you see there's the spinner saying searching for materials, and then it's going to load the material data. So this is a function up here that passes that parameters. It's going to pass it this get materials within a region, which is a built-in method in the wrapper. So you pass it a postal code, and then you pass it the plant distance and the parameters. And what's kind of happening a little bit behind the scenes with that method is it's using another library called like, I think it's pgeocode, that's looking up a postal code and grabbing the latitude and longitude. And then it's kind of using that to determine like the distance from around. It's getting the radius around that, and then you see based on the plant latitude and longitude values that you're getting from EC3 if they fall within that radius. So yeah, and then we just have a few things here that'll kind of like if you don't get anything back, like kind of stop it and warn the user. So rather than throw up an error, you can use this st.stop and like issue a warning that says, like there's nothing within within that radius. You might want to try adjusting your distance or other parameters. So just kind of a warning to the user. And so now we're going to see here, like these are the materials that were returned. The way it's like returning. So this st right, you can see here that it has like the records listed here because it's returning 100 at a time. So it's a little bit slow to collapse there, but this is what the JSON looks like. So you can see there's a ton of information just within that planter group field. But these are kind of like those fields that we specified to return there. So that's kind of the querying of the database part, which is kind of the bulk of the work. Then there's the cleaning of the data. Just for the sake of speed, I might not run this because it's going to be like, you're not going to see anything different. But essentially what we need to do in this step is we're going to convert everything into a pandas data frame. And then from there, we're gonna like you can remove outliers. So I've created a function here that's just gonna say anything more than, I think we set it to 3 standard deviations outside of the mean. We're gonna ignore that. What I found happens with a lot of the data that's in EC3 is because it's manual input from manufacturers, occasionally there's something where like somebody put in like something that's clearly like orders of magnitude off from what it should be for like the global warming potential or something. And so like I'm just trying to get rid of those outliers basically in that case.
So EC3 doesn't do its own kind of like QC check. You kind of
I'm sure they have some stuff, but from what I've seen, there's some things that slip through the crack, and like it's also still a lot of it's very new, so I'm sure they're kind of working on improving some of those features of it. But for now, I would just like make sure if you are using it, like make sure you're inspecting your data carefully to make sure that like you don't have any. If you have like pretty big outliers, I'd be suspicious of them. If something, if all your concretes are within like a 200 to 500 global warming potential, and then you have one that's like a 10, it's probably wrong. Maybe we'll get there, but I don't think anyone's there yet. So yeah, and then there's also some other cleanup that we're doing, like I mentioned, as far as converting the record. So that function here, kind of like checking all of the different unit types that are being stored in the data and just converting everything into PSI. And then, I'm going to get the plant name. So I have to kind of dig into this JSON here to get the plant name. And then, get the latitude and longitude and all that kind of data. It's kind of nested within that response. So I just have to know where to go look for it. And so this is basically converting that like EC3 response into just a dictionary that will then get converted into a pandas data frame, which is a lot faster and easier to work with. So then the last and a couple steps here. So that first visualization that I made was the plot data. And maybe what I'll do is just for the sake of speed, I'll just run the last one, but that includes step 5 as well. So map data. So you'll see that running here, and I'll just kind of get that queued up because you'll see it might take a minute or so. So in step 5 in the plot data, this is kind of that box plot that we see here. So super easy. This is just, like one function, the px. So we've imported the Plotly Express library as px, and then Streamlit has kind of a like recognizes that Plotly, so you can do that st.plotly chart function, which is a built-in Streamlit function, and then you would just pass it that chart that you just made, and it kind of you can like set a theme and theme it as Streamlit, and so that kind of allows, you'll see if I hover over here, there's some stuff with like, I can, expand this and do all sorts of stuff with it. And this is like a quick kind of interactive plot that you can make. So pretty much any sort of data visualization that you can make in Plotly, you can kind of pass it into the Streamlit Plotly chart function and like visualize it in your app. And then the last one here is the map that you see down here, which is again like a built-in. I'm using the PyDeck module. So that's PyDeck. And what that is here is a little bit more involved just as far as like setting the styles and stuff. I mean, like most of these lines are just like aren't necessarily required, but just to kind of set the style a little bit to match how our purple and whatnot. And then you kind of create this like group it by the plant name, the latitude and longitude, and then you're gonna kind of like set your view state. So that kind of like sets it like how far in you're gonna zoom in. So I've kind of just set it to, I've calculated the mean latitude and longitude of all the plants, and then I've kind of like set it to zoom in around that area. And then again, this pydeck.chart or pydeck_chart is a built-in Streamlit function that you would pass your map to. So I know that was like really fast, but you know, I that's kind of why I created the GitHub repo. So if you wanted to kind of go through it again and look at all the code, you can do that. But happy to answer any questions.
Yeah, if y'all have any questions, drop them in the chat and we'll make sure Jared gets to them. I do have a question. So Streamlit, I guess, has a number of like compatible libraries that allows it to produce kind of all of these graphics. How easy or hard is it to, I guess, write your own kind of custom component for Streamlit?
You're saying like if you were to have like a custom sort of visualization that you can't make with one of the Python modules, it is kind of like limiting in that regard. Like once you get into custom stuff, there is like some stuff you can do with like Markdown and CSS. Like you can have like a custom CSS file, I think, that you can attach to it. But you are gonna like run into limits pretty quick when it comes to like trying to create a custom visualization. Like that's kind of where Streamlit's not great for that type of thing. Streamlit modules. There's like somewhere in the documentation where it says the different components that you could find. Well, here's like the gallery. But yeah, this has like examples of some of the built-in like modules that you can use. But yeah, I think there is in the documentation. If I looked up like Plotly or something, it's probably, yeah. So I can come here and see like these are all types of chart elements that I can pass it. Other kind of like random stuff you can find in here, but it's all pretty well documented. I mean, there's a lot. So like if you are creating like a basic prototype, you can usually find something that gets pretty close to what you want. But yeah, once you're trying to get something super custom, you're gonna hit the limitations. There's no sound.
No sound from me. Thank you, Amadeo. Hit the like button if you can hear me. If you can't, you know, go somewhere else on YouTube. But I was just saying.
Hopefully you can guess what Timon is saying. But if you can't, he's saying smash that like button.
Smash it. And I was saying, just thanks to Jared for all the work that he did putting this together. If there's any questions, we've got about 2 more minutes. I mean, we can keep going for 10 minutes, But if there aren't questions, we won't keep moving on. This was
Oh,
pretty good.
maybe show us the deployment step, Jared.
Oh
That
yeah.
would be cool.
Yeah, so and again, this is covered like in the blog post here a little bit. Um, but basically you'll kind of like you'll you'll set it to say deploy an app. So if you're deploying it, I will say like it's a lot easier to deploy the app publicly than it is privately with Docker. You kind of have some more steps with the Docker. But if you're just deploying your app on GitHub, you just kind of like come here, say like deploy the app, you would put in your repository name, which branch it's on, and that main file path. So like in this case, it's looking at that demo app.py, which has everything in it. So that's how like, even though my repo has all these files in it, it's not looking at those. And then you just hit deploy. There is like advanced settings here. So that's like where you would put in like any secrets. So if you have any like bearer tokens or anything like that. So like as you're testing again, those would get stored in your secrets.toml file. But then like when you go to deploy, you'd basically just copy and paste everything that's in there into that advanced settings. And then you just kind of launch it. It might take like a minute to like process or so, but it's like very easy.
I have
Wow,
another
that's
question because the last show was about Airtable and using Airtable APIs. Could we connect the two and do Airtable and Streamlit for, I don't know, a new
Yeah, I
Your
mean, you
Desk
can
University website?
for sure. I mean, like I don't know if we get all the functionality that we can get on the current website just within Streamlit, but we can definitely connect Airtable API and
we
Streamlit.
get cooler charts at the minimum.
We could have
We
an auto click to tweet directly from our website. That, anyways,
we
that
can
that's
run
really
some
cool.
visualizations of all the speakers and or something where they
But that
work. I don't
does
know.
that does maybe bring up the question around kind of the limitations, and you talked a little bit about them. But like, if you were to imagine like the extreme case, and let's stay on the content of sustainability, and the extreme case of like what Streamlit can do with someone who isn't an advanced Python developer, what would you say your outer limit is? And this is today's outer limit. Tomorrow it might be different.
Like, you
What could be
mean as far
built?
as how hard it would be for them to get something up and running in Streamlit?
Like
Or
what could you build if you were to build like what could you build in Streamlit? Could you, you know?
I mean, I think you can build like you can all the things that are in the galleries, for example, or all that code is public. So like any app that you look at that's not deployed privately, you can go look at the code and, copy paste or whatever.
Mhm.
Um, but yeah, I think you can get pretty far even as like a beginner Python user. I think the tricky thing is that like if I've just taken a Python class, now I have to like I could get a little bit confused in like what is like an, a Streamlit function versus what's like
Mm,
not. I could see that getting a little bit confusing. But it is like the documentation and everything is like very like it's very good and there's a lot of resources out there, just like YouTube videos on it. So you can, I think like if you have like a very baseline Python knowledge, you can still get something like pretty useful up and running within a matter of like an hour or two.
yeah. I guess last question is what about I lost it. My question I had it. Oh, so what other apps have you seen that do something like this? Because there's a few Python-based applications. So can you kind of talk about the other possibilities if you're not going to use Streamlit with Python?
Yeah, I mean, like, I guess the big one would be like Jupyter Notebooks, right? Like, it's kind of similar in terms of like being able to easily interact with the code and like, Jupyter, you can plot things in Jupyter using Plotly and you can use pandas and all that kind of stuff as well.
Mm-hmm.
So I think that's probably like the most similar, but it is kind of different in terms of like with Jupyter, it's more geared toward like the developer or like somebody who's wants to play around with the code. Whereas like Streamlit, the app that you're building doesn't is the target audience doesn't have to be somebody that knows how to code. It could just be, anyone who knows how to click a button. So it's a little bit different in terms of like who the audience is, but as far as like being able to quickly like iterate with the code and like, you know, plot something really quick and see it and tweak it and plot it, like it feels a little bit similar to Jupyter Notebook in that regard.
Mm-hmm. Yeah. I know I'm familiar with Victor also, which I've seen Topologic has been doing a few apps. I think that's all Python based. They have a subscription model. I think Streamlit does too. I can't remember if you mentioned at the beginning about like what the limitations are of the kind of the free tier of Streamlit.
Yeah, I mean, I think it just has to do with like they'll like kind of shut down the app after it's unused for a certain amount of time. But like once you rerun it, it'll like sort of wake it back up again. Yeah, I don't know like as far as how they make money, I'm not really sure. Um, but I'm sure there's
Sorry, I need to get
some
to
sort
the
of
screen
paid
here.
can't of it.
Yeah.
Yeah, I
That's
can't
fine.
find it
That's
right
fine.
now, but
Lebo, any closing remarks? Thanks for hosting. Give him kudos in the chat for the energy that he puts into this. And if you're watching this afterwards, you can always find us on Discord, where we're interested in kind of continuing the conversation.
Yeah, find us on Discord. Thank you, Jared. This is freaking amazing. I'm excited to maybe test this out.
cool. Thank you guys.
Yeah. Well, there you go. There's another great episode of Your Desk University. Thank you to Jared for all that, teaching us using Python. I'm personally interested and curious about this. I've definitely gone the deep end of JavaScript. But stay tuned next week. We're doing our final 2 weeks of the semester, final 2 shows. We're going to learn about IFC.js and about REST APIs, specific things that are very important to the AEC industry. And I think for those developers, whether you're visual scripters or language scripters, I think you'll find something really interesting. And now I have to find the closing scene. So hold tight here for a second while I do, because switching between 3 speakers, 1 speaker, it all keeps changing. So bye. All right, we are off the air.